hey guys.
It's Monaco behind the camera.
Yep, milk with the paper.
This lab
is about solubility curve.
Oh yeah, what do you got to say?
I got to say that we're going to be using table G, right? Little background information, solubility. So, table G is going to tell us specifically in 100 grams of water how much stuff is going to dissolve at what temperature. All right, and for solids, as temperature goes up, solubility is going to go up. For gases, opposite. As temperature goes up, solubility goes down.
Yep.
And of course, remember, it's only for 100 grams of water. So on the test questions, you play tricks with 50 grams of water, 200 grams of water, which is going to change our solubility.
But the most important part there is that it can be used to identify unknowns.
Well, that's what we're going to do now today.
Right.
So we have an unknown for you that's you are going to dissolve, and then you are going to bring back out a solution so that you can see what temperature it dissolves at. Okay, so your purpose is to identify the unknown solution that Monaco and Milk's created for you. What you're going to end up doing is on a various, we have, right, 2, 3, let's show real quick, right?
That's a data chart. We actually made this one for you this time.
Right, so there's 2, 3, 4, 5, up to 10 grams in each vial.
Solute.
Water. In water. And so now you can, at the temperature in grams, right, so 2 through 10 here, and the temperature at which it was, and you're going to plot this out. And I don't have a marker.
Right behind you.
Oh, is it right behind me? Oh, sweet.
Yep.
So when I'm done with this could look like that.
Right.
Or, it could look like that.
Mm-hmm.
And I can take just that one curve and compare it to my table G.
Yep.
And based on its slope, figure out, hey, this looks really most like that.
So we know your unknown's one of those
True.
On table G. It's got to be.
It's got to be. And I believe we specifically chose 10 grams of water, correct?
Right, so we're going to have to multiply
it by 10.
All our solute masses by 10 to match the graph.
To match the graph. All right,
but that's easy.
Let's step over in the lab and see what's going on.
So
here is our array
of chemicals.
All labeled up. 10 grams, 9 grams. I got 8 cooking.
8's in this, 8's
right,
dissolving.
And then 7 through 2. Okay, so you need to keep track of which one you're doing when.
Mm-hmm.
You're going to need to do them all. I'm going to take 8 out right now.
So this sample is 8 grams of solute in 10 grams of water. So this is equivalent to 80 grams of solute in 100 grams of water.
Right.
And what did we have to do to get ready? This is part of our procedure, right, Mr.
Right,
Morris?
so we got to turn on the hot plate, of course.
Right.
Get the water going.
Beaker of water about halfway full.
And then get this, your sample in there. And it's got to go from
that
white powder in the bottom to no powder in the bottom.
Fully dissolved.
Right, you might need to stir it a little bit. What I want you to be careful of is we are all going to be using these things over and over. I don't want this thing coming in and out a lot. And once you get going, you know what I'm saying? Like, once you're
gentle.
in, you're in. And when you're done, you're done.
Right, you got to be gentle.
Not a lot of in and out, not a lot of in and out, not a lot of, very gentle, because I don't want this thing breaking.
These test tubes are fragile, and so are the thermometers. And if you ruin the sample, that's a data point.
For everybody.
That everybody's going to miss.
Right.
Now, so we heated up this water, but it doesn't look like it's quite boiling.
Well, I see the bubbles everywhere, though, so
we got this
really
to about
close.
80, 85 degrees at the most.
Sure.
And then what's that you had over there?
Well, that's just a cold water bath that I'm trying not to use too much, but I also don't want you guys in video for like 25 minutes waiting for me to make this thing go.
Because we got to show you what temperature you're recording, what we're looking for.
So now, there it is. See it?
All of a sudden, you see that? That's
not
dust. Hold on a second. Let me zoom in a little bit this way.
Right.
That's not dust.
See those crystals?
They disappeared.
There they go. See them?
Oh, they are.
See them?
Having trouble. Stop. Slow down.
Just trying to kick them up. Trying to kick them up.
They look like little needles.
Yeah. Almost like it's snowing in there. As soon as you see that,
you record the temperature.
You record the temperature.
And so in this case, we're not going to tell you what it was, but that's what you record on your data chart. So for this 8-gram sample, 8 grams of solute.
Here I would record my temperature.
Whatever temperature that he finds that it starts to snow at, crystallize. And if you want to, record 2 or 3 times. Try it twice or 3 times.
You can actually just pop it right back in a hot bath for just a second.
Look at all them crystals is gone now. They're gone.
Because it's hot.
It was hot. And the temperature went way back up over 50. So
And now we can cool it off. It shouldn't. Once you get it going, it shouldn't take too long to get through each
The
one.
slower you cool it down, the more accurate your test result's going to be.
Absolutely.
He got crystals to show up after putting it in the cold water bath, which got it to cool a little bit quickly.
Right, it's actually still heating.
It's still heating up. So for that reason, don't go to the cold water bath because your results aren't going to be as accurate.
Yeah,
If you let it cool down
I'm not
slow.
trying to find out what that temperature is while it's in the cool water bath at all. I just wanted to reverse the heating to make it at least start cooling.
You might
a
see
little bit of agitation.
a little bit of black stuff in the bottom there. That's an impurity.
Yep,
that
black's
is
not what I'm looking
your
for.
crystal.
You're looking for these white
starting
shards.
to see it, I thought.
And you might want to make sure it's dry to help.
Kind of looks like a snow globe start to form in
Ooh,
there.
there's
There's one. I thought I
There's
saw
one.
one.
What I noticed is that if you give it a little swirl that's nice and easy without breaking this, guys.
That
and maybe
crystal
I'm good
showed
at
up
this.
and then it dissolved again.
Right, so that's why I'm not counting it. It's almost like it fell in from the top. You know what I mean? I'm looking for a change. And you'll see it. It'll
We're
be
getting
pretty
there.
big.
Keep going. We got to get this. It's going to start to show. It's got to.
Yeah, we got about 2 or 3 more degrees. We'll
Yeah,
see a change.
Starting to see little things show up. And I know they might look like little floaties of dust at first, but that is the precipitate that we're looking for.
Yeah.
There, I'm definitely starting to see more in the video.
All right, good.
Yeah, but we
I can
want
barely
nice
see some.
shards of like glass-like snow falling
Right.
down.
Now I'm starting to really see them pretty
Yeah, there we go.
Yep.
Starting to get there. And if you stop mixing for a second, they might really start to go. But either way, the point is...
good. You want to be kind of consistent with each one.
Yep. There we go.
Yeah, starting to see them a little bit, right? Mm-hmm. So you start to see a major change.
And don't turn away. If you start to see,
Yeah,
don't
that's
turn
when
away because all of a sudden you'll turn around and it'll be like a...
Right. Yeah. If you,
It'll
I don't
be
know if
full.
you guys can see my eyes in this, but my eyes have not left this liquid ever since I got close to being able to see in something.
For sure.
Absolutely, because I want to be right on top of it.
When
I don't
the
want to
temper-
be checking out
there-
somebody else's sneakers. I see a lot of dust in there now.
Looks like dust, but there
See
we go.
that?
All of a sudden,
see a lot more.
all of a sudden,
Look at
if
that.
you
See,
stop
it's
mixing,
everywhere.
it'll
I
start
wanna
to
take the
really,
temperature.
really go.
Yeah, see, I want to take that temperature
He
right
would
now.
record this temperature as his data point.
Absolutely, because see how it's like all the way through? Oh, look at it. Now you can see the snow.
So it
Bam,
looks
take
like
the
a
temperature.
snow globe. He would record that
Bam.
number. We're not going to show you because you got to do it. It also gets a little cloudy
Yep.
because again, it's a solid
Yeah,
precipitating.
see?
Wait.
You see, really see it now. Is it helpful with
Oh
my
yeah.
shirt in the background?
Now
or no?
stop mixing, and it looks literally like a snow globe. That is how you know when your data point's done.
Right, because now it's precipitating out. It's not. It's right on the edge of the temperature it will dissolve at. Mm-hmm. Right. If I heat it up 1 degree, it's all going to dissolve perfect.
So
don't
give us a
use
quick
that.
rundown of the rest of it. So that was 1 point. He'd have a number for this value right
So
here.
I need to do it, and not in any order. I need to do it for all 9 of these test tubes.
And so
I
it's
can
gonna
get a
take a
plot.
while.
It is going to take a little while.
Maybe
but
more than 1 day even.
Maybe more than 1 day. Maybe maybe you team it, and maybe you pick 2 of them, and your lab partner picks 2 of them, and you get your 4 data points for the day.
Right.
It could be like that.
Is there any cleanup?
Well, I would remove and rinse my thermometer.
Yep. And then put that sucker.
It's kind of cool. I want to cap it. I'm missing my cap.
It's right next to the hot
See
plate.
it? I'm going to cap it.
Sit it there.
Sit
Boom.
it there.
For somebody else to use.
Yep, and it's done.
So you're saying that with the data, you can kind of team up and do class or group data
Yep.
to streamline things.
Yep.
We're going to have a data chart here, grams versus crystallization temperature, which you're then going to chart.
Yeah, and I mean, that is kind of negotiable, depending on how many groups are in here at a time.
Right.
I mean, to get you guys out of here, maybe I assign 2 or 3 to each group
And do
let you guys
class
share.
data. That's
I mean,
okay.
we'll see if there's just 1 or 2 groups in here. You guys have got a lot of work to do, so we'll see how it goes. But I know we've done it in the past that way. But
So
we'll see
just
how it
a
goes.
graph and analysis and a
then
CEI. Claim.
CI like normal.
The identity of the solute is.
Who is it?
Which one of those chemicals from table G was it?
Right,
David and
why?
Evans. I know why and interpretation. How accurate do you think your results were? Basically, if your curve compares really closely to table G's,
Yeah.
you were pretty good.
And-
If your curve is close enough,
Right. Well, I'll tell you right now, we're not going to be looking at length. We're actually going to be looking at slope. is
Right.
the slope. The slope is what's going to match.
Right.
And it'll help you. There's
We'll
all
know
names.
that which one we got going on based upon how it looks
Right.
once you graph it all. So
That's it, guys.
thanks very much.
Lab.